Okay. Hi, goedemiddag. Don't worry, my talk will be in English. I'm the Scala team lead at Typesafe. I've been hacking the Scala compiler since 2007 when I decided that all Scala needed was for world domination or higher kind of types. So you might call them higher order generics or type constructor polymorphism. That was kind of how I started out with Scala, and so I guess you can blame or thank me for that. Since then, I've kind of come to my senses, and in 2.10 I did the pattern matcher, for example. And so right now I'm leading the team at Typesafe. So I'm guessing you've heard Scala is this functional object-oriented programming language that we didn't talk about during the keynote for some reason, but that's okay. We're also a tool that aims to make you more productive, and we think our unification of functions and objects does just that, and that's the main goal for us. Under active development for over a decade, we just celebrated our teenage, the beginning of our teenage years, sorry, and growing pretty steadily, and yeah, I would say vibrant community. That's one of the things that we at Typesafe are actively working on, is to help the community work on Scala, get started with Scala. So we see ourselves as the stewards of the project. Not just because, you know, our not-so-secret sauce for the reactive platform is Scala, and so everything that we do is implemented in Scala. We do provide great Java 8 APIs, so you're welcome to use it from Java, but I think you'll have a little more fun doing it in Scala. So quickly about that community, when we look back at 2.10, which was about the time that I joined Typesafe and left EPFL, the community had about 10% of the commit pie that you see up there, and 2.10 was a pretty massive release with a lot of features that I won't go into today. And then the split between EPFL and Typesafe was about 50-50. So in 2.11, we focused on stabilization and modularization. So that's why the absolute size of the pie got a lot smaller, but the relative size of the community, of the community's contributions tripled. So very proud of that, very thankful for that. And EPFL is as well, so those students can now focus on their dissertations and writing papers and doing more research. And so we're still about 50% of the work. We try to do the more boring stuff. So similarly, another metric that I kind of made up is what's the core team size? And I just define that as who is doing 90% of the work, so who's doing repeated, who's sending us repeated pull requests. So a handful of people both at EPFL and Typesafe, so we're not a big army of Scala compiler hackers or anything like that. But there is a pretty big army out there. Stood at 33 regular committers, and it grew by quite a bit in 2.11, and one of our goals at Typesafe is to keep this growth going, and yeah, so thank you very much for that. No pressure, keep up the good work. If you have, yeah, thank you. I know getting started with Scala both as a contributor and as a user might not always almost be the easiest thing you do. I hope it will be the most fun you'll have with programming languages, but come talk to me if you have ideas about how we can simplify this or things that kind of kept you from contributing, for example. I'd be happy to see what we can do there. So to the meat of the talk, I'll be talking about 2.12, and it's easy to summarize Java 8. We're very excited about having all those features available to us as well. We've been jumping through a lot of hoops over the years to compile functions to the JVM, to compile traits to the JVM, and those hoops just got a bit wider and less fiery. So that's pretty great. So I'll talk a bit about the nitty-gritty later. So one of the things that I did want to touch on is that I know a lot of people are still in Java 6 and are planning to be on Java 6 for quite a while longer. Well, that's not a problem. We do intend to publicly maintain 2.11 well past the Java 7 public end of life. And if you need commercial support beyond that, just give us a call. But to make it easier to switch back and forth between 2.11 and 2.12, they'll match features as closely as possible, of course, with Java 6 being the common denominator. So a little bit about what you can expect from the rest of the talk. So I'm going to start off by ranting a little bit about functional programming. I'll give you definitions and make some controversial statements and see if I can keep you awake and from running away to lunch. I can't really see you, so if you're too hungry, that's okay. So then I'll show you how to use Java 8 APIs. So for example, the streams, which we're pretty excited about. How to use them from a Scala REPL, which is a great way to experiment. I hear that that's coming to Java at some point. And of course, vice versa is equally important, so I'll talk about that as well. And then at the end of the talk, I'll give you a bit more insight into what kind of bytecode we generate. And the gist of it is, if you get too hungry by then, Java C8 style bytecode is what you can expect from the 2.12 compiler, as well as from the 2.11 compiler if you're running under the Java 8 experimental flag. So what is functional programming? What is that all about? Why is everybody getting so excited, or why is this such a controversy? Well, we just call it programming in Scala, really, and that's roughly all I have to say about that. I mean, as we all know, programming is about dividing into abstractions of the right size and then composing them back together without losing any safety. You want to be able to factor out common patterns and then later use those all over your code rather than duplicating them and have slightly different bugs in every instance of that duplicate. So, and our claim is that very often functions are the right size, and I'm very happy that I don't have to really go into too much detail, because that was basically what the keynote was about, or at least the first part. So very often this kind of behavior, if you want to react to an event, or you want to do something to every element of a collection, you want to do stuff in parallel, you have a ton of data and a little bit of code, so why don't you just ship the code to the data instead of the other way around? All of these are examples of what functions are good for. Now, if you need a bigger abstraction, we got you covered with that as well, of course. So we got traits and objects, and at heart, Scala is an object-oriented programming language. So now onto my definitions to really get the fiery debate going. So in my definition, OO is programming with objects, and I'm not trying to be facetious or something. I mean, objects are your values. That's the key thing that you think about. And from that, it follows that you have a closed set of methods. You tend to think of, that's what I have for my object, and you want to define new subclasses and new subtypes, because that's kind of the problems that we deal with most often in modeling and simulation, which is where OO has its origins. And, surprisingly, functional programming is programming with functions, and you kind of swap the expression problem around, because that's what it tends to be called in the computer science literature. Now you get extensibility of your functionality for free, but it's harder to get to insert new types in your system. So commonly you don't have subtyping in functional programming languages, which allow you to do stuff like that. So then there's a whole other bunch of labels that people like to apply, either specifically to OO or to functional programming, and I tend to disagree. I tend to think that all of those labels apply to both OO and functional programming languages. There's no reason you can't have an object-oriented language that's pure. I mean, it might take a lot more typing in Java, but you'll get there. And the same thing holds for laziness and strictness. Scala is not a lazy language, but I think it's perfectly suited as a functional programming language. And I'm not even going to talk about static and dynamic typing, and I'd rather not talk about math. All I'm going to say is that I think math makes you a better OO programmer as well as a functional programmer. In Scala, we think there's no need at all to go deep in math to be productive. Scala is a tool. Functions are a great abstraction. If you want to talk about monads, there's other talks. I'm not going to go into that too much. We like to hide them away. So to capture the essence of what I've been saying before is that we think of functional programming as object-oriented programming in the small. And if you want to make a recursive definition here, you could say an object is a bundle of functions, and that's how programming language theorists model objects, or used to model objects. They just took a bunch of lambdas, abstract over themselves, and so on. And you can implement late binding and all that pretty easily. But a function is actually just an object with one method, and that's what we see now in Java 8. That's a very convenient encoding, and that's what we've been doing in Scala for the last decade. We call that method the apply method, and you can omit that apply name when you call a function, which is just an object on which you can call that apply method. So in that sense, Scala doesn't bolt on functional programming onto an object-oriented language. It's a nice unification. And like I said before, functions are often the right abstraction. They're what really captures what's different between different parts of your code. And a very nice property of functions, and combined with purity, is that they're easy to understand. They're very often, the amount of code that you can keep in your head, and you just need to know what's coming in through the arguments to understand what's going out. You don't need to think too much about mutable state that's shared. That's the devil's work, as a wise man said a couple days ago. And that only holds if those functions are pure. And so purity is usually a good idea. I'm gonna go too much into this, but I have to say reactive at least once. And that's what my contract says, sorry. So the reactive programming paradigm and everything related to that really is built on this idea that you have units of behavior that you can distribute over a cluster or cores on your computer or threads or whatever. I don't think it needs anything more for motivation. So Scala is a very pragmatic language in this sense. It doesn't force purity on you. It just gives you a little nudges once in a while saying, hey, why don't you type file here? It's just as many letters. So let's take a minute to just look at some contrived code that I fit on a slide here. And on the left is what you might write when you like mutation a lot. And so you want to compute some local variable. So you make it mutable, you set it, you don't initialize it, or you do in this case. You check some expensive condition and you compute an interesting result, and then you return it maybe after doing some post-processing or something. So really what you want to know at the end of this block here is what is the value of x, and you need to know what the dots are in order to answer that question. Now when you go to the right side, which is where Scala wants you to be, you just look at how val x is defined, and that's all you need to know. So a couple of things to kind of snarkily note. If is an expression in Scala, so we don't need a ternary operator. So get that, we have one fewer operator compared to Java. At least for this one. And I think that's all I wanted to say about that slide. So I think that the take-home message here is statements cause side effects, and that's why we don't have them. It's an expression-based language. And to me, that's one of the key things about pure functional programming is that you want to focus on expressions. Statements, they push you towards mutation, and once you start sharing or seeing that mutation across different parts of your program, you're into trouble. So like I said, Scala is pragmatic. Mutation is a side effect, just like, let's say, checked exceptions. The compiler doesn't bother you with either of those. So if you feel like, mutation makes sense in a certain piece of code, so let's say you have some kind of profiling counter and you want to increment it every time this lambda gets called, hey, just, go for it. The IDE will show you those variables in red, but that's the extent we'll go to nudge you to purity. So to conclude this kind of, what I think functional programming is like and what we want it to be like for you when you're programming in Scala is, it's not that controversial. And so when people say stuff like that, everybody is like, what? When, is it time for lunch already? Like, yeah, sure. And so, but when you say stuff like this, everybody's like, higher order functions, combinators, composition, what? But it's really just the same thing. If you think back to our definition before, you can think of objects as just a bundle of functions. So when a method takes an object, it's actually abstracting over functions. So it's a function abstracting over functions. That's a higher order function. That's all that means. So when a function takes a function, like map taking whatever transformation you want to apply to all the elements of your collection, that's what we mean. And so, by the way, Scala does that on the type level as well. That's what I mentioned earlier. To convince you I know what I'm talking about, it has higher kind of types, which are basically type parameters that abstract over type parameters, and they're pretty handy when you're defining library abstractions like the collections. But I'm not going to talk about that today. So to give you a couple of examples, what function composition does for you. Ripping out iteration is an obvious one to everybody. Abstracting over nulls now with optional in Java 8 or option in Scala. And an extension or generalization of that is validation, which I think is a very nice pattern where, let's embrace failure and let's be able to tell your users what the failure really resulted from. So by expressing your computation that might fail as a set of functions, you have a handle on that failure and you can tell what's going wrong. And the same pattern comes back over and over again. And my favorite one is the Scala async project, which lets you work with futures in a delimited scope. And in that scope, the macro, in this case, will get a handle of all your future computations and run them off in parallel, and you don't really have to know that any of that is going on. So, as we like to say, you just flat map that shit, and that's function composition for you. Really quickly, something about high-tech plumbing, and I don't have a nice graphic like the keynote today, but that's kind of what I was thinking of. Types guide your values in the right destinations, and if you've been to any of the reactive streams talks earlier this week, that's really what I'm talking about, is you look at the signatures of your transformations and you know what they're going to do. So once you ship them off to your data center, you don't have to wait to run for a couple hours and see if you shoveled all your ints into int buckets and all your strings into the string buckets. But I guess that's kind of obvious if you're coming to a Scala talk, so I'm not going to spend too much more time on that. So that doesn't mean that you shouldn't test, obviously, and the type system, at least in Scala, doesn't have that ambition. We're not a proof assistant. We don't want to make the type system so rich that you can just say, well, it compiles, let's go home. And finally, and that's, I think, the most important point, is when we're, implicitly this is, of course, a competition with Java 8. So, I would claim our type inference makes your lives a lot easier when you're programming in Scala. And you could say, sure, my IDE, fills in all the blanks for me, and maybe that solves your problem. But no, actually, you have two. You have to maintain all that boilerplate, and when you refactor, the IDE won't regenerate that boilerplate for you. It's there. It's the same problem as when you generate getters and setters and so on. So in Scala, we have pretty powerful local type inference. What that means is that it operates within methods, not interprocedural, like other functional programming languages, because we believe that public type signatures are your contracts, are your documentation, and no one wants to infer Java doc. Right? I mean, maybe it'd be better in some projects, but I don't recommend not having your return types inferred, even though in principle we will do that for you. So to quickly recap, the key thing here is that a function is a value, and it lives on the same first-class citizen status as all the other values in your language. So you have a nice way of expressing literal functions. You can pass them around, you can abstract over them. And because pure programs are easier to reason about, Scala nudges you towards that by thinking in terms of expressions. You don't want the side effects that are caused by statements. Very often they don't help in program understanding. And like I just said, both types and monads are things that we want to have, to be working for you behind the scenes. It's great for library implementers to have a rich type system and to think in terms of very abstract concepts, because that's what you're doing. You're trying to capture a lot of different patterns in terms of categories or other mathematical ideas. And that's a great vocabulary to have when you're working on those kind of libraries, but we really try to hide that from the user. So our for comprehensions, for example, are expressed in terms of for each and flat map and so on. But they don't have to be a monad for the for comprehensions to hide the ugliness for you. And my personal favorite, pattern matching, but unfortunately I won't have time to talk about that today. So let's get to really where Java 8 and 2.12 meet. And I'll give you an example of what you shouldn't be doing with SAN types, much more easily spawning new threads yourself. But I guess you can kind of see what the syntax looks like, or the syntax savings. And I really like the way that they introduced function types, at least from the operational perspective, on the JVM. And so we're implementing feature parity so you can easily use SAM-based higher order methods from Scala.